Yes.
Oh, okay.
Mosa. Mosa. Yeah, I just want to open my notebook. No, not that app. This app. It's so hot, guys.
Yo, we're getting 36 at midday.
What are we on? This cold water, yeah? Right here we're on, I know it's 30 something, but it's 30 something.
It's 29.
29. What does it feel like? What's the real
It feels
feel?
like 30.
Still feels like 40 something.
Wait, let me refresh and see. Yeah. It's 29. It's 32. Feels like
32.
29.
No, it doesn't feel like 29. It feels like 39, bro. Feels like 39.
What?
It feels like 39.
And we're at its peak right now. It's at its
Yo.
peak.
Wait, no, Busha, you said we were on page 39, you and I, ne?
Tinabek Sigu 23, sequence and series, yes, sigma notation.
Sigma notation. Okay, cool.
Siyokwenza finite arithmetic sequence. I think that was the next one, 1.4.
Finite arithmetic series, yes? Wait, series or sequence?
Series.
Series. Okay, finite arithmetic series. Awesome. Alright. So I want to bring everyone up to speed so that when you do your self-study, at least you get a feel of the pace which we should all go at. Because the girls and I, we've already started with functions, but I don't want to leave you behind.
Yeah.
Yeah. So, oh yeah, 1.4 arithmetic series. Okay, cool. So with an arithmetic sequence, we usually have a sequence of numbers, and there's a common difference, a first term, and Tn is the nth term, as expressed in this expression, Tn equals A plus n minus 1 times D.
So, sorry, just to disturb you, isn't that Kali load shedding this side? So if I get kicked out, it's that swapping.
Okay.
Okay, cool.
Finite arithmetic series. Alright, cool. So just revising there. If we want to sum all of these up, if you look there on page 24, if we want to sum all of these, we'd obviously say term 1 plus term 2 plus term 3. And if we want to do that for the first 100 integers, we would have to say the sum of 1 plus 2 plus 3 plus 4, right?
Yeah.
2, 3. And if we're going to do that to 100, we'll stop at 100. Now, if we want to sum this sequence, we first write in sigma notation. So our index starts at n equals 1 at the bottom, and we have n to the right of the sigma sign. And at the top, which is where we end, we'll have 100. And then this will give us the sum of the first 100 integers, right? Okay, cool. So there's some interesting story there that I always, I guess, gush at. A mathematician called Friedrich Gauss discovered that, and he discovered this when he was 8. So their teacher gave them a problem because bebam soup, and he's like, okay, add the first 100 numbers, like 1 to 100, just as we've been doing now. And he then figured that he could write the numbers in ascending order and write them again in descending order. So in other words, from 1 to 2
To
to
100.
3 all the way to 100, and again in descending order, which is 100 plus 99 plus 98 all the way up back to 1, and then he adds the terms together, so to be 101, 101, the sums of all of those. And then once he got that, he would simplify the equation by making the sum, which is the same for ascending and descending order. So the sum to 100, we'd make that the subject of the formula. So basically, all that he ended up doing is getting the same sum twice. And what that means is the sum to 100 for ascending order is the same as the sum to 100 for descending order. So then he gets twice the sum to 100 of the first 100 integers, and this equals 101 times 100, and that then gave him 2 times 100 sum to 100 equals 10,100. And then when he divided by 2 on both sides, the sum to 100 he got the sum to the sum of the first 100 integers is 5,050. So that's the answer on page 25, right? And that answer then gives us a way to find a general formula for the finite arithmetic series. So if we're going to add up to the last term being the upper bound on our sigma sign, and the first term being 1 on our index. So for the nth terms that we're going to add up, that gives us the sum to the nth term. And all we do, just like when we were proving the formula for arithmetic sequence, the general term for arithmetic sequence, the same thinking is applied for the sum to the nth term, where it's the first term plus the first term plus the common difference, which is the second term, plus the first term plus twice the common difference, which gives you the third term. And all of this all the way to the last term. So the last 3 terms would be last term minus 2 times the difference, plus the last term minus the difference, plus the last term. And that is what Carl Gauss did with the ascending order. And you sum the terms up. And you do that again for the same series, but this time in descending order, such that the last term is going to be added to the first term, and then for the second term in the series would be last term minus common difference, and then the third term would be last term minus twice the common difference, and you do that all the way until you get to the third to last term, which is first term plus twice the difference. Second last term would be first term plus common difference, and the first term would be a. Then when you add all of these up, what ends up happening is you have first term plus last term for all of them, right? Because the common differences, twice the common differences, etc., they all result in 0, and you could say cancel out. And you're only left with the first term plus the last term. So think about that thing that Carl Gauss did, where he was adding the 1 to the 100, the 2 to the 99, the 3 to the 98, all of those give you 101. So in the proof, they just give you a plus l, because the common difference, or terms that have common difference in them, cancel each other out to give you a plus l. Right, and then all of this equals twice the sum to the nth term. And when you divide both sides, or rather, since we don't know, let's say if it was 100 terms, then it would be 100 times the a plus l. But since we're just working with the nth term, then we'll have to multiply n by all the terms a plus l, because it's so many times that a plus l is multiplied. Just as in the proof, it was 100 times that the 101s were multiplied. So now that we have twice the sum to the nth term equals n times the first term and the last term. I'm tired, sorry, because I slept late last night. Then the sum to the nth term becomes n divided by 2 all times a plus l. And that's the general finite series addition formula for the finite series. The general formula for finite arithmetic series. Another thing we can also do from our general term for Tn, right, which equals the first term plus what's this, n minus 1 times the common difference. If we assume the nth term to be the last term, then we can substitute that into the sum to the nth term formula, so that the sum to the nth term becomes n over 2 into the first term plus, now when we substitute a into n minus 1d, we'll get a different animal altogether. And this then gives us n over 2 into 2a plus n minus 1 times d. And this equals your n over 2 into a plus the last term. If I'm not mistaken, I think you do get these formulas in the exam as part of the formula sheet. And you can get asked to prove this formula, but I think it's pretty straightforward and simple. If you give yourself enough time to just study it and do it step by step as they're illustrating, you might find that it's quite easy to understand. Yeah, so we can follow another example if we want to work out the sum to the 20th term for the arithmetic series of, or rather sequence of t to the tn equals 3 plus n minus 1 times 7. And if you want to do that, you can do it number by number, term by term by term. So the example there on page 25, if you want to do it, you can add the terms like that individually. So you can do that just to illustrate how long the process takes to just keep adding the, like substituting n equals 1, finding the first number, and doing that 20 times. Because you see there they did it 20 times, and then they compare how that works out when you do it with just the formula. So let's start off first by doing that sum term by term and see how long it takes us. And then we're going to compare with how long it would take if you just substitute a equals 3, d equals 7, and n equals 20 into that formula we just derived. So the sum to the 20th term would be, so let's start there with adding them manually, one by one by one by one. So if we're going to do that, it would be 3 plus 7 into n minus 1. And we're going to do it term for term for term. So our first term is going to be, if we substitute using sigma notation, n equals 1, we'll have 3 plus 7 into n minus 1, and then that's 3 plus 7 times 0, and that just gives us 3. And we do it again for n equals 2. We'll have 2 minus 1 is 1 times 7 is 1 plus 3, that gives us 10. If we do that for n equals 3, we'll have 3 minus 1 is 2 times 7 is 14 plus 3, that gives us 17. If we do that for n equals 4, we'll have 4 minus 1 is 3 times 7 is 21 plus 3 is 24. We do that again for n equals 5, we'll have 5 minus 1 is 4 times 7 is 28 plus 3 is 31. We do that again for the sixth term. So 6 minus 1 is 5 times 7 is 35 plus 3 is 38 plus what's the 7? 7 minus 1 is 6 times 7 is help me out with the calculator. But Nobita, are you following one on the page 25?
I'm on page 25 and I'm trying to follow Shem.
So so scroll a little bit to the bottom.
Yes.
At the bottom of the page, right? There's a sum to the 20th term, and that equals sigma notation n equals 1.
20.
Yes, that one. So they've written there 3 plus 10 plus 17, etc. And we want to
20.
They do that 20 times. So we have to find each of these terms, term for term for term, as we add by substituting. You see, from sigma notation, the same way we were doing in our worked example and our homework. If we say n goes into, if we substitute rather the n there as 1, we're into 3 plus 7 open bracket n minus 1. If we substitute 1 there, we'll have 3 plus 7 times 1 minus 1. So that becomes 3 plus 7 times 0, which is 3. And then,
14?
okay, so to get the first term 3, we
said 3 plus 7.
7, yes, open bracket, 1 minus 1, because we're substituting n equals 1.
Yeah.
So in the place of n, we put 1. So we get 0 there. 0 times 7 is 0. And we're just left with the 3. So when we substitute n equals 2, we get 2 minus 1 is 1. Times 7 is 7 plus 3. That gives us 10. We do that again for n equals 3. So we have 3 minus 1. That's 2. 2 by 7 is 14 plus 3 is 17. That's a third term. Do that again for the fourth term. Term number 4, it becomes 4 minus 1 is 3 times 7 is 21 plus 3 is 24. Do you follow so far?
Yes.
Okay, so we can do that as many times as needed. So in this case, 20 times. And you'll start seeing that at some point, you either start needing to use a calculator or it just gets too repetitive and too darn boring.
Yeah.
So because of that, even though we might get to the correct answer of 1,390, you'll find that it's actually a lot easier to, and more sensible, I like the word they use, sensible, to just say, okay, our first term is 3, our common difference is 7, and the nth term is 20. And then we use the formula sum to the nth term is n over 2 times 2a plus open bracket, n minus 1 times the common difference. And that's the formula that, so at the top of page 26, that's the formula that they listed there. And then when we substitute all of these terms that we know, a, d, and n, we'll have sum to the 20th term is 20 divided by 2 times 2 into a is 3, n is 20, and our common difference is 7. And that gives us 10 into 6 plus 19 times 7. And with a calculator, you should be able to, in one calculation on your calculator, get the correct answer of 1390.
Which I'm struggling with.
Okay, how are you using it on your? How are you punching in the numbers on your calculator?
I don't have the square brackets. Well, maybe I do. I just struggle with the calculator.
It's
I
just
hope you told them
brackets.
that I'm new to this thing, right?
It's fine. Don't worry about the square brackets or having them on your calculator. They're just a way to neatly visualize the formula so that you don't confuse the curved brackets with more curved brackets, and also so that you can see how many brackets are used for which term. For example, if you were to put another like round bracket on the other side of 1, it might look confusing to the eye, so don't worry that much about it. What you can do is you can start off by saying, what's 20 minus 1? Maybe you can do that in your head or whatever, but you can just write there your 19, you multiply it by 7, you put that answer there, and then you take the 2 by 3, and you have 6. So you're going to have 6 plus 19 should be 25, and then, or something. Is that correct?
No.
It's not correct, yeah.
I think it's going to be
130, because I didn't multiply with the 7, that's correct, yeah. I didn't multiply with the 7. So anyway, you can say 19 by 7, and then you add 6 to that, and then you're going to multiply it by 10. And then you get the correct answer. So let's try that quickly. Take the n, which is 20, and subtract 1. What does that give you?
19.
Multiplied by 7?
100 and something. Wait, no, it's not.
Should be 133.
133. Yeah.
And then add 6.
139.
And then multiply that by 10, which is 20 divided by 2.
Add a 0 at the end.
Yeah, so you get 1390, right?
Yeah.
Alright. Cool. Let's quickly do an example. If we have a problem that asks us, or rather we have a sequence, Tn is 7n minus 5, and we must find the sum of the first 30 terms. The first step we'll have to do is to use that same general formula to find A, which is T1. So then 7 into 1 minus 5 would give us 2. And then if we want to find the second term, we will have 7 into 2 minus 5, which is 14 minus 5, which is 9. And for term 3, we'll have 7 times 3 minus 5, which is 21 minus 5, and that's 16. So we've got the first 3 terms of the series or sequence, and what can we determine from that?
Common difference is 7.
Okay, and what's the first term?
2.
2. Okay, and then we have n, right, which is our nth or whatever, to where we add or whatever. So that means we can use, just like we use the formula to cut out the lengthy process of doing things term by term, we can use that same formula for sum to the nth term of an arithmetic series. So we can write the formula down. Sn equals n divided by 2 times 2a plus n minus 1 times the common difference. And we can just substitute everything. We've got, what's the value for n?
30.
30. Then we're going to divide that by 2 sharp. What's a?
2.
Great. And then n is 30. What's our common difference?
7.
7. And then we just do the calculator maths. So in your calculator, what's 30 minus 1?
29.
29. Times 7
A lot.
should be 150.
203 or something.
203. Oh, okay. Jeez, where's my maths today? And then, so it said it's 203
3.
plus 4,
207.
207. And then we multiply it by 30 divided by 2 or 15, and that gives us how much? 3105. Give me. All right, so we've got the sum to the 30th term is 3105. Yeah, ne. All right, so do you get the idea so far?
Yeah, I do.
Okay, cool. So we're gonna skip worked example 8 because it's exactly similar to that. But, or maybe let's do it, because instead of giving you sum to the nth term, they've actually given us the last term. So now we get a chance to use that other equation that is shorter. So worked example number 8, which is on page 27. Right, so we've got minus 5, minus 3, minus 1, plus all the way to plus 123. And the first thing we can do here is what? Would finding the common difference help us?
Probably, so that you can tell you.
Okay, maybe let's give it a try. So if we're going to work out the common difference, where do we start?
Oh, it's a negative. I don't know.
Remember for arithmetic sequence rather, common difference is the difference between two terms that come after the other.
Well, so you take the second term and you minus it to the first term.
Yeah.
Which page are we on? Which page? 20 what? 7.
Yeah.
Oh, okay, yeah. Second term minus first term.
Okay, so we're gonna have minus 3 minus negative 5, right?
Yeah.
Okay, and that gives us 2. And we can also do that for t3 minus t2. And that gives us minus 1, which is term 3. And our second term is minus 3. So that's going to be negative 1 plus 3, which is positive 2. So our common difference is 2. Our first term is negative 5. And we also have our last term, which is 123. So we can use the sum to the nth term of n over 2 into a plus the last term, right? But we don't know what n is, so we'll need to determine that. So before we get to that formula, we can find what the subscript n is. So Tn is 123, which is our last term. The nth term is 123.
Is it not the first term? Oh, Tn, yes. N
Tn
being
is the
last
nth term,
number.
yeah, the last term in this case. So that equals, from our sequence formula, general formula, it's a plus n minus 1 times d, right? And we've got
Yeah.
a, which is negative 5. We don't have n, but we've got the common difference of 2, and all of this equals 123. Now we can solve for this equation and make n the subject of the formula. And how we're going to do that? We have negative 5. We have 123 equals negative 5 plus 2n. So we multiply the 2 by the n, and we also multiply it by the negative 1. And we add those two. So we're going to have 2n minus 2. So then in the end we'll have 123 equals negative 5 plus 2n minus 2. Then we take the negative 2 and the negative 5, we add them up, they give us negative 7. And all of this plus 2n equals 123. When we apply additive inverse on both sides for 7, we get 123 plus 7 equals 2n minus 7 plus 7. These two reduce each other to 0, and we have 2 times n equals 130. And then we divide both sides by 2, such that 2n divided by 2 equals 130 divided by 2. Therefore, n is 65. So now we found that term number 65 is 123. So the number of terms that we're adding, the number of numbers that we're adding is 65 numbers in total. Now using that sum to the nth term, n divided by 2 of a plus l, this becomes s sum to the 65th term of 65 divided by 2 into the first term is negative 5 and the last term is 123. Then we do the math and the sum should be 3,835.
It is what it is.
So the other problems, they're also quite similar. In the one worked example number 9, we've got the second term, the common difference. Then we'll have to work out the first term. And we're also given that the sum to the nth term. So we'll also still have to determine n, and after determining n, we'll then find that the sum to the 37th term is that 2,146. Worked example 10. In this case, we're given the sum of 36 first terms is, or maybe let's do that one because it sounds complicated enough. And this one is on page
28.
All right. So we're given the second term, or rather we're not given the second term, but the problem states that the sum of the second and third terms equals 0, right? So T2 plus T3 added together give us 0, and that the sum to of the 36 first terms equals 1,152, right? And we have to find the first 3 terms in the series. Here what we can do is get a little creative. T3, okay. And how we get creative? The way in which we prove the formulae is what we're going to use. So we know that T1 is A, T2 is A plus the common difference, and T3 is A plus twice the common difference. That's from our proof when we're deriving the formula to sum a finite arithmetic series. So what we know is that if we add T2 and T3 together, we get 0. So we can substitute T2 as A plus D and T3 as A plus 2D, such that if T2 and T3 are 0, then it's A plus D plus A plus 2D. That gives us 0. When we open up our brackets, we have 2 times A plus 3 times D equals 0. And we can make that equation 1. Right? Now we have to look for a second equation that we're gonna solve at the same time with, at the same time. That's what simultaneous means. Yeah, at the same time with equation 1. But let's find equation 2. So we know that the sum to the nth term is n over 2 into 2a plus n minus 1 times the common difference. And the sum to the 36th term must equal, when we substitute, 36 over 2 into 2 times a plus 36, n is 36, so it's 36 minus 1 times the common difference. We don't know the common difference, we don't know the first term. But we do know that the sum to the 36th term is 1152, and then this equals 18 into 2a plus 35 times the common difference. And this gives us, if we divide both sides by 18, then 1152 divided by 18 gives us 64, and then we're left with 64 equals 2 times a plus 35d. Now we have got two equations that have both a and d, and we can solve them at the same time. So our first equation is 2a plus 3d equals 0. That's 1. Our second equation is 2 times a plus 35d, and that equals 64. If we subtract two from 1 or 1 from 2, so let's say 2 minus 1, then 2a will subtract 2a and give you 0. 35d will subtract 3d and give you 32d. And 64 minus 0 will just give you 64. Bless you.
Thanks.
Okay. And then we divide both sides by 32. And how many times does 32 go into 64? Twice, right? Okay.
Yeah.
So d will equal 2. So now we have our common difference, which is 2. And we can substitute that into the first equation. And then 2a is negative 6 and A becomes negative 3. So now we found our first term. It's A. Sorry, we haven't found our first term yet. Sorry. We've got our common difference, right? Oh, we have found A, my bad. Our first term is A, and it's negative 3. Our common difference is 2. So in order for us to get the second term, what must we do to the first term?
Minus.
Okay, let's start here. So term 1 is negative 3, right? Term 2 is the first term plus the common difference. Term 3 is the first term plus twice the common difference.
Twice the common difference.
Yeah. So what's A is negative 3, right?
Yeah.
So if we add our common difference of 2, how much do we get? Positive 2. How much do we get?
0.
No, it's minus 3 plus 2.
Yeah.
What's the answer there?
Minus 3 plus 2.
Yes, what's our answer there?
I want to say minus 1, but I'm not sure.
No, it is correct, but just punch it in on your calculator just to be sure.
Yeah, I just moved down the number line.
Oh, okay, cool. Then we do again our first term minus 3. What is that? What is that?
Yes, that's it.
Oh, okay. So we've got minus 3, which is our first term.
Guys, are the guys still there?
Yes, we're all here.
Are you seeing what he's doing?
What is he doing?
I can't see, so I'm like trying to follow.
Oh yes,
Hey.
we can see what he's doing.
Yes.
Naka sokola kam.
So you must share screen. That's why you must get Zoom. And share
Zoom has not been agreeing.
See. People with Apple products.
So each time I need to go back to the video and start the same lesson. I do the same lesson twice.
Oh.
Just bear with us. How we're gonna. Okay, but if we substitute our common difference of 2 into A plus 2D and our first term of negative 3, then we get minus 3 plus 2 times 2, which is minus 3 plus 4, and that gives us 1.
1, yeah.
Yes. 1. So our first 3 terms are negative 3, negative 1, and 1. Okay. So far we've done those that have arithmetic series, sum of an arithmetic series using the 2 formulas. There's a little discussion there. If the first term in a series is t equals, or rather t1, then the sum to the first term is just t1. The sum of the first 2 terms will be s2, which is t1 plus t2, and which we can arrange if we make... Oh, this is so cool. Sorry about that. So if we take t1 as our first term, and we want to add the sum of the first term, or rather the sum to the first number, then s1 is t1. But then that means the sum to the second 2 terms will be t1 plus t2, and we can make T2 the subject of the formula, which is just T2 which then becomes, let me do this, which then becomes S2 minus T2 equals T1 plus T2 minus T2. So if we apply additive inverses, then oh, I should not use that one. That's 2, 1, 1. Then that's another one there. So T2 would be sum of the first two terms minus the first term. And we could also determine the third and the fourth terms in the series with regards to the sum to the third and the second term. So for any term Tn, then the sum to the nth term minus the sum to the nth term minus 1 is valid. And this is for n is an element of, it starts from 2, goes to 3, 4, and so on. It doesn't start at 1. But for T1, that equals S1. So that's just the discussion when we have to calculate the value of a term given the sum of n terms. Alright, so we are going to look at, so you and I will look at some homework examples during the week, but I want us to move to the finite geometric series. So remember our geometric sequence Tn equals a times r to the power n minus 1, which is the one we use to calculate if everyone is born of 2 parents and those 2 parents each have 2 parents, etc. So now we're going to add each of those people in each generation. And we're going to use the same kind of proof on page 31 at the top as we did with the one for the sum to the first 100 terms in an arithmetic series. So we're going to use a similar method. And for our proof, sum to the nth term would be in ascending order. First term plus first term times common constant ratio plus first term times constant ratio squared plus plus AR to the n minus 2 plus AR to the n minus 1, and that gives us our first equation. And now in descending order, we'll have to multiply the constant ratio by the sum to the nth term of the geometric series, right? And we do that so that each of the terms that we're going to add, the r's that don't that have the power 2 must correspond. So that means it's only in the wait, Joy, what was our conclusion when we did this one? It was that if we have a there starting in for the top series, then what happens at the bottom series? It was that
I thought we multiply the Sn with r.
with
Right.
r, okay?
So the a automatically falls
Falls
off because
off.
it's multiplied by r. We can't have an
Oh, so we don't have, yes, okay, cool. So if we multiply each of the terms in the first sum by the constant ratio, and we add that to the first sum to the nth term. So even though we'll have a to the power r plus a to the power r squared, etc. Plus ar to the n minus 2 plus ar to the n minus 1. Okay, plus AR to the N. Okay, so what happens is, in our first sum, we have the first term A, and as you can see there on page 31, underneath the A, there's like a blank, there's a space there after the equal sign. Can you see that?
Yeah.
So that space there is just to show that we could have had something there, but because we multiplied by R, then it's no longer there. That term corresponds to the one that looks like it above it. So it's like they don't really shift, but they kind of do shift. So it's like to the right. Yeah, they shift to the right. Plus yes, a positive shift to the right. And then all the terms that correspond become one on top of each other. And we eventually end up with AR to the N as our last term. And then we add everything up, right? So when we add everything up, we'll have, or rather we subtract. So if we take sum to the nth term minus R times sum to the nth term, then we'll have A subtracting nothing, and it's just A, which is from the space that we have there after the equal sign. A times R is going to subtract another A times R, and that gives us a 0. A to the R times R squared is going to subtract A to the R squared, and that gives us 0. And we'll do that so many times that A to the power, A times R to the power n minus 2 is going to subtract A times R to the power n minus 2. That gives us 0. A times R to the power n minus 1 is going to multiply A times R to the power n minus 1. That also gives us 0. And then at the end, we're left with A times R to the power n. Yeah. Then, after subtracting, we can take out the common factor of sum to the nth term on the left-hand side of the equation, so that we're left with 1 minus R. And on the right side, we're left with A plus, or rather, A minus.
Oh, now the top failure, Shema.
You must keep zoom. You're suffering.
I'm gonna get zoom. Okay, but I've cleared space, so I'll put in zoom. Don't worry. I'm gonna install it during break. So yeah, we've got A to the power, or A times R to the power n. And okay, that's supposed to be a minus there. Oh no, it's minus because it's subtracted. Yes. Okay, cool. Then we'll have sum to the nth term equals, we take out common factor of A, and then it minuses R to the 1 minus, it's A times 1 minus, what's my math? Yo guys.
Yo,
Today, I don't know where my head is at. But yeah. So yeah, that's A times 1 minus R to the n, and then you divide by 1 minus R. And then that gives you the sum to the nth term for a geometric series. But R can never equal 1, because if R equals 1, then we have a denominator of 0.
And you cannot divide anything by 0.
And that gives us sum to the nth term, which is undefined, or rather, you can't make sense of it in the real number system.
Error.
So your calculator will give you an error.
Yeah.
Also, the formula is easier to use when r is less than 1. So in other words, if r, the common ratio is like a half or quarter or a fraction, then the formula is easier to use. Alternatively, instead of subtracting r times the sum to the nth term, we can subtract sum to the nth term from r times the sum to the nth term, and that's just going to give us this. Okay, let me do this. R times Sn minus Sn will equal a times r to the nth term minus a, and if we take out common factor of sum to the nth term, we'll have the sum to the nth term equals a times r to the n minus 1 over r minus 1, and again r cannot equal 1, and this works best with r that is larger than 1. So we can do a sum of a geometric series from worked example 11 on page 32. And we're simply given that in sigma notation, from k equals 1, and we do that 6 times, 32 times a half to the power k minus 1. That's our sum. So we must first work out our first three terms. And T1 we find when we substitute k equals 1. So if we substitute k equals 1 into the expression to the right of sigma sign, we're on page 32 now. Wait, are you still connected? Yeah.
Yes, I'm following.
Okay, cool. So we substitute k equals 1. So we're gonna have k minus 1 at the exponent there, right? So 32 times a half times k is 1, and we're gonna subtract 1 at the exponents there. So now any number that is to the exponent 0 equals 1. So if you have a number and you raise it to the power 0, then that number equals 1. So in your calculator, you can just punch in 2 to the power 0. There's a button there that has y, a big Y and a small x.
Yeah.
On your calculator, look for a button that has a big Y and a small x, like at
It's
the top
1.
right corner. Yeah. So that tells us that any number raised to the power 0 is 1.
It's 1, yeah.
So for this, when we're finding term 1, if we substitute k equals 1 there, we're going to have half to the power 0, which is half to the power 0 is 1. And then we multiply that by 32, and that just gives us 32. If we take k equals 2, why's my eye twitching?
So your time.
I think that's it, yeah. If we take, what's this, 32, or rather k equals 2, and we have a half to the power 2 minus 1, which is 1. So that means we have a half to the power 1, which is just a half. And we multiply that by 32. We'll get a half to the power 1 times 32, and that gives us 16. If we have k equals 3, so we have 32 times a half to the power 3 minus 1. 3 minus 1 is 2, and a half times a half, or half squared, is a quarter, and 32 divided by a quarter, or rather divide by 4 is 8, or times a quarter is 8. Right, so now we have a series that is 32 plus 16 plus 8 plus 2. And in order for us to continue, we have to find the first value, which is 32, but we also have to find a common ratio, which is T3 minus divided by T2. And if we do that, what's our common ratio?
T3 divided by T1 or T3 divided by T2?
The latter. So T3 divided by T2. How much is that?
0.5, a half.
It's a half. Okay, cool. So our common ratio is a half. Now we're going to look for the sum of the geometric series for that expression. And we have to find the sum to the sixth term, because from this, if we do that upper bound minus lower bound plus 1, we'll get that we have 6 terms in our series. So if we have 6 terms, then we know we'll have to find sum to the sixth term. So writing down our formula, Sn equals A into 1 minus r to the power n over 1 minus r. The sum to the sixth term would be 32 into 1 minus a half to the sixth power, and this is over 1 minus a half. Sorry. Then this gives us 32 times 1 minus 1 over 64 divided by a half, and that's gonna give us 2 times 32 over this 64 over 64 minus 1 over 64, and this gives us 64 times 63 over 64, and the final answer is that if we add all the numbers to the sixth term, we'll get a total answer of 63.
Yeah.
This then tells us that the sigma notation we're given from k equals 1, and we do that 6 times, of 32 times a half to the power k minus 1, then that sum adds up to 63. Straight back. Okay. So now on page 33.
Sorry, Pato.
Yeah.
I've got my gardener here, so we'll have past Uzofuna Madam. It's almost done. It'll only take 3 minutes.
Okay.
Okay.
Are you gonna go see him now?
Well past.
Okay. Do that, and then.
So we can take a comfort break at 1:30, girls.
Thank you very much.
All right, at 1:30 we'll take a comfort break. All right, cool. The second one. But that's just 1 hour, so we'll take a comfort break and then we'll come back, right? Okay, cool. My head is somewhere else here. It's in a lot of places. Look, example 12, page 33.
Can I just ask a question?
Yeah, sure.
With my lame ass sharp calculator, is there a video I can watch on how to use all of this? Because I will not want to break down anything into terms during an exam.
Kunje, what's the model number? It's sharp EL503. What is it?
531WH.
531WH. Okay.
I will probably have to look it up.
Video. Should probably look that up and also share it on Classroom as well for everyone to Yeah. Because I mean, I assume you didn't change your calculator because it's been working fine for you all this time.
Yeah, I'm actually tasked to buy calculators for some school competition.
Okay.
So
So
I'll
you'll get
probably
yourself.
steal one of those. And they're pretty cool calculators.
How you've got access to budget? Can't you just add like an extra calculator? Like say it's a bonus prize or something like that.
It'll just get lost. I'll buy the exact number minus one.
Yeah, something like that, you know.
Yeah. No, ladies, theft is wrong.
Yes,
It's not
very
theft.
wrong.
It's
Very,
not
very
theft. You are like, what do they call it? Compensating
I'm
for losses.
I'm portioning resources.
Yeah, you're
Okay, yeah.
portioning resources. Could be a loss or something, but hey, who knows?
Yeah.
So in this problem, T4 is 32 and T1 is -4.
That's negative.
Alright. We don't know the common ratio, so we're gonna have to find that. But we do know the first term is -4. So if we have Tn is a times r to the power n minus 1. That is correct, right? 4, 2. Yeah, okay, cool. We can work out the common ratio if we have that nth term, Tn, and we have the value of r to the power n minus 1. So T4, t to the fourth, or rather t subscript 4, the fourth term is 32, and this equals the first term a multiplied by r to the power n minus 1 would be 4 minus 1, which is 3.
4 minus 1.
So it'll be 4 minus 1, which is 3. So 32 equals -4 times r cubed. Now if we have r cubed and it equals, if we divide both sides by -4, so -4 times r cubed will equal 32 divided by -4, and r cubed will be, what's 32 divided by 4? Should be
Like 8 or something, I don't know.
Yeah, it is 8. So if it's negative, then it's going to be -8. And then the cube root of r to the power 3 would be r, and that gives us -2. Oh, cool. So our sequence goes from -4 to +8 to -60. So our r is negative, and this means that the signs of the terms are going to alternate. So the geometric series is -4, and then goes to +8, then goes to -16, then +32. So we only get this when our common ratio, constant ratio, is negative or less than 0. So now that we have that, the general terms, Tn would be -4 times the common ratio is -2 to the power n minus 1. Then we must use sum to the nth term to find what n is, since we've determined the constant ratio. But we know that the sum to the nth term is 84. So quoting the formula first, we'll have sum to the n term is a times 1 minus r to the power n over 1 minus r. And we know that this equals 84, the sum to the n term. And if a is negative 4 and we substitute, constant ratio is negative 2. We don't know what n is. And this is over 1 minus constant ratio is negative 2. This here is 3. Then we'll have negative 4 plus 4 times 2 to the n equals 84. Or maybe let me not do that because it's gonna complicate things. Yeah. All right. So now we have negative 4 over 3 times 1 minus negative 2 to the power n. So 83 times negative 84 times negative 3 over 4.
Would that be plus 2 simple terms? Negative 4 multiplied by 1 plus 2 to the power n.
Oh, okay. I'm avoiding multiplying throughout with the negative 4 because
You won't be multiplying throughout. I got it here. Just solving this part.
this part here.
Yeah.
I want to take this fraction to the other side.
Okay.
So that's why it's like that. So then I'm just left with 1 minus negative 2 to the n on this side. Then I'll have negative 63 equals 1 minus negative 2 to the n. And if I do additive inverses, so plus 1 plus 1. Oh no, it's supposed to be minus 1.
Oh.
So minus 1, then I'm having negative 64 here. These ones subtract each other, give you 0. Then I left with negative into negative 2 to the power n. Then dividing throughout by negative 1, we have 64 equals negative 2 to the n. Negative 2 to the n. So, okay. If we are going to square or to the even power of odd numbers, we get a positive number. Or negative number, we get a positive number, not odd numbers.
We can just factorize.
Factorize the 64. Yes, we can factorize the 64 to say how many times do you have to multiply 2 by itself to get to 64? When I was
Or is 32 times?
no, that's 2 okay, I guess factorize still means that. But what I want you to think about is if you have the number 2 and you keep multiplying the number 2 by itself, how many times do you have to do that operation until you get to 64?
You have to do it 32 times. No.
No, that's no.
64 12. Oh, 84 times.
How many times do you have to multiply 2 by itself to get to 64? Not how many.
2 times.
Yeah, so in other words, like 2 times 2 times 2 times
5
2.
times. No.
Try again.
I think I'm right.
It should be 6 times, but I want you to think of it
Six.
like that. Yeah.
2 multiplied by itself 6 times gives you 84.
Gives you 84. Okay, and if you do it 5 times, it's 64. Is that correct? Two, four, 6. So do it 6 times. So 2 times 2, and do that operation 6 times. So try it again and do it 6 times.
It's 5 times.
No, it shouldn't be 5, it should be 6.
Yes. Hey.
This calculator, you can't see on this calculator, Moza. How do you see? It doesn't have that solar power thing where you can charge it in the sun for a while. Okay.
5. It's 5 times.
Really? But we get 6 times when we do it.
How? You count the first 2, then you get 6 times.
Yes, you have to count the first 2.
Oh.
Yes. So then, in the same way, because that power, that n, is a even number, it's an even number, then the sign has to be negative. So we can do the same with -2. So -2 to the power 6 will still give us 64. So try that again with -2. So do -2 times itself 6 times.
Yeah.
You get 64, right?
Yeah.
Alright, so if we write -2 to the power 6 equals -2 to the power n, then what we have as -2 is called a base.
Yeah.
And the bases are the same on either side of the equal sign. So -2 to the power n equals -2 to the power 6. That means n equals 6, because you can only make sense of that equation to be true if n equals 6. If n was 5, then that equation will not be true. So then that gives us the final answer that the constant ratio is -2, and that the n to which we must add these numbers to get 84. We must add 6 terms together to get 84.
Yeah.
Okay. You want to take that comfort break now?
Sure.
Alright, cool. See you in 5-10 minutes? 5 minutes.
5 minutes.
Alright. Zoom. Let me update my Zoom.
So honestly, how do you use the calculator? Let's do a regular work.
Do this. So when you need the answer, does it show the answer?
Are you funny?
It's not funny. It's not funny. It's funny. This guy's hilarious. This guy's hilarious. We're not to Polokwane to the kids.
Usually go gym
I'm not giving you shit. I'm not giving you nothing.
That's what your teacher said.
Yeah. And she's like, I'm not PNA, I'm not CNA, so I'm not giving you anything.
Ooh. That's cold.
Yeah. She just taught us how to handle our things properly. In other words, just to take care of your things.
Yeah.
And be more responsible. Because now if people always have to do things for you, you won't be able to account for yourself.
Yeah.
So yeah. And I was so scared of her in grade 8. But then maybe when she ran a direction, look at right pay live around. You never around this or you need to homework, we didn't video call tomboy, so Miss Pandroid. And then in class she's just the sweetest woman ever.
I'm not CNA.
I'm not CNA, I'm not PNA.
It's fine though. I wish it could take out cool air. But how do I record meetings? How do I record meetings in Zoom?
Yeah, sure. She can be mean outside of class. Very mean.
Yes, you can photo album.
This is our principal. And follow me, I'm right behind you.
Your principal is a black guy.
Yeah.
Yeah, that looks fine. Notifications. That. Okay. New schedule today. Let's see. Science class starts today at. When are we starting class today? Starting at 2 o'clock. Zoom is gonna want me to upgrade for 2-hour-long classes. That's the thing about it. I just remember.
Upgrade how pay?
Yes, start paying. I don't want to do that yet because I haven't increased your guys' class fees.
Why don't you make them 1 hour then 1 hour?
Still 1 hour 60 minutes, not 40 minutes. Yes, check this out. So if I say 1 hour, so a plan that goes more than 40 minutes. So we can do 30 minutes, then take a break, and 30 minutes. 30 minutes record, take a break. Oof, so much admin, but it's fine. You can work with that.
You're doing it for Lobushi.
Yes, 1, 2.
I'm saying let's buy an air conditioner.
Yeah, I should totally do that.
Buy an air conditioner so we don't have to start doing this heat.
Yo, bruh. And I was thinking that when I was at the funeral, the way it's so hot here at this funeral, I'm gonna feel as hot in my class, so.
See, you know how you say, I should buy an air conditioner.
Now we'll get there, don't worry. We'll definitely get there. Repeat every week. Yeah. Sorry.
Did you know the sound you hear when you listen to a seashell is actually the sound of your bloodstream, not the ocean. Which I understand, or in Congress, I only hear the ocean. But
It sounds like it. I mean, it does sound like it.
what does a bloodstream sound like? Let's start there.
I would like to think it sounds like the pulsing of your heartbeat.
Like, what does it?
Is terug, Nana?
You're back?
Yo.
Alright. Let's carry on. I'll schedule this during break. Okay. So we are back. We're back. Okay, so let's quickly do worked example 13, and we will use the general formula of a geometric series to work out using in sigma notation rather. Index equals 1 to 8. K to the power 1 over 2, or rather k times half to the power n equals 255 over 64. Page 34, ne? Worked example number 13. Yeah. So we must, our objective rather, is to find the sum of the geometric series to determine k. And k is an unknown that is multiplying that, I guess, expression half to the power n. But we can still find, or rather express, term 1, which is k times a half to the power 1, which is a half times k. Term 2 is k times a half to the power 2, which is a quarter times k. And term 3 is k times a half to the power 3, which is an eighth of k. So the first three terms of the series become 1 over 2k plus 1 over 4k plus 1 over 8k plus 2. And now that we have the first three terms, if we take out the common factor here, k goes into a half plus a quarter plus an eighth plus all the way to wherever. And this equals k multiplied by, from n equals 1 of 8, a half to the power n equals 255 over 64. Okay, cool. So I just want to explain that real quick. We're already given that if we add the 8 terms of the series k times a half to the power 1 over a half to the power n rather. If we work out the sum to the 8 terms of that, we will get 255 divided by 64. We can take out k as a constant to the other side of sigma notation so that we can deal with just the terms in the series and find the common ratio. And the constant ratio rather is going to be found by dividing T3 by T2, and that's going to be 1 over 8 over 1 over 4, and this is 1 over 8 times a quarter, which is a half. And we can do that similarly with T2 and T1. 1 over 4 over 1 over 2, which is 2 over 4, which is a half. So now that we found our constant ratio of a half, we can find the sum to the nth term, which is a into 1 minus r to the n over 1 minus r, and sum to the 8th term becomes, our first term is a half, our constant ratio is also a half. Oh, okay, n is 8, and 1 minus r is 1 minus a half. When we do the math, a half to the power 8 gives us how much? 2, 4, 8, 16, it's about 256 or something like that. So how much? 2 to the 8?
2 to the power 8. Or half to the power 8.
Half to the power 8 is how much?
Give me a decimal.
Half to the power 8.
That's not what it normally does. Anyways, 1 over 256.
1 over 256.
Yeah.
Okay. So yeah, 1 minus 1 over 250, so that's 256 over 256 minus 1 over 256 times a half over a half. This times 2. These become 1. Alright, so we're just left with 255 over 256. Okay, so if we take, so now the sum to the 8th term becomes 255 divided by 256, and 255 divided by 256 equals sigma sign, bottom is n equal 1, top is 8, 1 over 2 to the power n, that whole expression equals 255 over 256. All right, then We go back to our original expression. If we have the constant k multiplying sum to the 8 or 8 times half to the power n to 8 terms, sum to 8 terms, that equals 1/2 times n. That equals 255/64. And substituting 1/2 to the power n, or the sum to 8 terms of that, which is 255/256. That's what is explained on page 35 at the top there. That equals 255/64, and then k becomes 256 divided by 64, which is 4. Yeah. Okay, this problem is quite, I need to explain it again. Yeah. But in any case, let's do together problem 2, right, of our exercise 1 to 9. I want us to just get a feel of how we apply some of a geometric series in actual problems where we don't necessarily have the answer in front of us. So we have a series 1, -3, 9, or sequence rather. And we must find T8, or the 8th term. And we must also find the sum of the first 8 terms of the series. So if we are having a sequence of 1, -3, 9, and we have to first determine its formula, where do we start? We have Tn equals a to the power r to the power n minus 1. No, it's Tn equals a times r to the power n minus 1. Yes, that's correct. Thank you.
So I have some notes.
I love some. I'll have just now. So we're looking for the 8th term. We have our first term, which is 1. Our constant ratio is T3 divided by T2, which is T2 divided by T1, which is -3 divided by 1, which is -3. Or 9 divided by -3, which is also -3. That means our formula for the general term of the sequence would be a is 1, the constant ratio is -3, and it's raised to the power n minus 3, n minus 1. Sorry, n minus 1. Okay. And that means the 8th term, T8, would be 1 into -3 to the power 8 minus 1, which is 1 times -3 to the power 7, which is negative what?
-3 to the
power 7, yeah. Should be a negative answer.
-2,187.
-3 to the power 7 is -2,000.
187.
Yeah. 187. Okay, cool. So the 8th term is -2,187. And the sum of the first 8 terms would be a into 1 minus r to the n over 1 minus r, and that gives us 1 into 1 minus negative 3 to the power 8 over 1 minus negative 3, and this would be, okay, when we work this out, this would be, that should be, okay, fraction 1 times 1 minus negative 3 to the power 8, 1 minus negative 3. Oh, okay. Where did I make a mistake? So the sum to each of these would be negative 1640. Oof. Okay. Wait, did I give this as homework, Joy? One exercise 1-9.
Yeah, but the first part we didn't do. We did only the second.
The second one. Okay. Okay, cool. So Nobuhle, you open page.
Yebo.
Have you opened page 35?
Yes, I'm on page 35.
Okay, so I wanted us to do problem number 2. We were given the first 3 terms of a geometric sequence, and we must find the 8th term of the sequence as well as the sum of the first 8 terms of the sequence.
Good.
Yeah, so for the first part, A, to determine the 8th term of the sequence, we'll have to find t to the 8, but we first must find the constant ratio, because we already have the first term, which is 1.
1.
So our constant ratio is going to be how much if we take t3 divided by t2?
I don't know.
Okay, t3 is negative 3, and t3 is 9, and t2 is negative 3. If we take 9 and we divide it by negative 3, how much do we get?
Negative 3.
We get negative 3, right? So that's our constant ratio. Now, you recall the formula for the general term of a geometric sequence? T to the n equals a times r to the power n minus 1. You remember that formula?
Yeah.
Yeah, so let's take that formula. We've got a equals 1, we've got r equals negative 3, correct?
Yeah.
So if we're going to find the nth term, and we're given that the nth term is the 8th term, so n equals 8. Let's substitute n equals 8 and substitute a equals 1 and r equals negative 3 into our formula Tn equals ar to the power n minus 1. So when we do that, we'll have t subscript 8 equals 1 open bracket negative 3 to the power 8 minus 1. I want you to write that down for us so that you can follow along.
Please repeat it.
Okay,
I wrote
so
it correctly.
okay, remember the formula Tn equals a times r to the power n minus 1? Yeah, now we're gonna substitute n equals 8.
Yeah.
We're gonna substitute a equals 1.
Yep.
We're going to substitute r equals -3.
Yeah.
And again, n equals 8.
Yeah.
So you should have T8 equals 1 open bracket -3 close bracket to the power 8 minus 1. Sharp. Now you can calculate that on your calculator. What's the answer there?
A -21, which is probably wrong.
It should be -2187. Try again.
No, I can, but I'm getting it wrong.
Okay, so you should get -3 to the power 7.
Yeah, -3 to the power 7, yeah.
Yeah. So you take -3 and you multiply -3 by -3 by -3 by -3 7 times.
But I shouldn't do that. Is there no quicker way?
There is. On your calculator,
Frustrated.
on your calculator, there's a button that has a big Y and a small x, like an exponent there.
Yeah.
Yeah, so punch in, I think you start off with 7 and then you, it's the old calculator, that's how they work. But I think you should start with the power, which is 7, and then you do the number, which is -3. If not, then it works directly from you start with -3 and then you do the 7. But try one of both. I want to see something. What does it give you when you try it?
Nothing close to the answer.
Okay, how did you punch it into your calculator?
-3 to the power of 7.
Okay, and what did you get as the answer?
-21,887. 2,187, sorry.
Yeah, that's the correct answer. That's fine. Alright, so now we're gonna do the sum to the 8th term. And sum to the nth term we know is a into open bracket 1 minus r to the power n close bracket, and all of that is divided by 1 minus r. So we're gonna substitute a equals 1
minus -3, which is a 4.
Yeah. So at the bottom the denominator is 4, definitely. At the top you get -3 to the power 8 minus that plus 1 and then times 1. So let's write down the formula. Sn equals a times 1 minus r to the power n close bracket equals 1 minus r to the power n. No, to the power 1, not n.
Sorry, equals r?
Remember that formula? Sn equals...
A times 1 to the power of...
1 minus r to the power n. Remember that formula?
Yes.
Yeah, write down that formula. So write down that formula.
Yes, I have.
And then we substitute now a equals 1, r is -3, and n is 8. We're going to substitute that into that formula.
Yeah.
Alright, now you substituted it, right? Okay, so take -3 and take it to the power 8.
Yeah.
Then multiply it by -1. Then add 1.
Yeah.
Then divide that by 4. What's your answer?
1640.
Yeah, that is the sum to the 8 terms, which makes sense. The largest, or rather the 8th term, is negative 2187, right? But the sum of the first 8 terms from 1 to 2187 is less than the 8th term. Why do you think that is?
Yeah.
Why do you think the 8th term is larger than the sum of the first 8 terms?
I don't know.
You don't know. Okay, if you look at the sequence, you start off at 1, and the next at positive 1, and the next term in the sequence is negative 3, and the third term is positive 9, which means the fourth term is going to be negative. So you're going to jump from negative to positive and negative to positive like that, you see?
Yeah.
So the next number after 9 would be how much if we take into account the formula Tn equals a r to the power n minus 1. Would be how much? It would be T4. Okay, 4 minus 1 is 3. R is negative 3. 3, 9, 27. Times 1.
Is that negative 27?
It's negative 27.
I'm asking.
Should
The
be.
previous one was a positive was.
Yeah, the previous number was positive 9.
I just multiplied 9 with negative 3 to get the next term because to get, I just did the reverse for getting.
No, we shouldn't do it like that. The correct way to do it is to just using this formula, Tn equals ar to the power n minus 1. We'll get the correct sign because you'll have 1 times negative 3 to the power 4 minus 1, so negative 3 to the power 3, which will give you negative 27 times 1, which is negative 27. So now, if you do the fourth term, you get negative 27, right? So that means half the terms from the first term to the 8th term are going to have negative signs.
Aren't they alternating from positive to negative, positive to negative?
And that's because, like Joy is mentioning, the numbers are alternating from positive to negative, but they're also doing that so like every second number or every even numbered term is going to have a negative sign, right? So when it has a negative sign, that means even when you get to the 8th term, and the 8th term is like 2187, summing all of those, then the even numbers in the sequence are going to be negative signs.
No, the odd numbers are going to be negative, so.
Are they? Well, most of the numbers are going to be odd, but what I want to say is the even numbered terms of the series will all have negative signs. So T2, T4, T6, and T8 will all have negative signs. And because they have negative signs, they will subtract, or rather, when you subtract them, when you add all of them up together, the negative signs are going to give an overall negative answer. You get it?
And I'm going to do it when I get the video.
Okay.
I love your honesty.
The girls love your honesty. Alright, so we're gonna end here, and then you and I on Monday are gonna do Infinite series. And then
Okay.
we should start functions during the week.
Okay.
Yeah. So we're gonna end here. And then we're gonna go for like an hour break. I think I need the hour, guys. Yo. Yeah, I think I need the hour.